Okay, so in this video let's try to build one simple sequential neural network from scratch using we are definitely going to use PyTorch. Mostly we are going to use activation here. So in the previous coding example, right, here we have used the linear equation, right, linear problem, and we build one linear model and solve it, mostly a regression problem. But let's say here we are trying to solve some classification thing and stuff, and we'll just randomly made up some data and we'll try to quickly finish, so that you can have the syntax understanding, okay, how in PyTorch you have to use activation and all. Okay, so first thing first, what you require, you'll be requiring the neural network module of torch and torch for working. So torch will be required for your utilities, and neural network is the base class for any kind of neural network you want to build inside torch. So these are the requirement. Okay, now first, so as I'm not going to write it down everything in this video, right, so the template and all those stuffs, those won't be required here. Our target is to understand the code, how and understand the structure, so that the same thing when you will be seeing in your company, in your projects, in your day-to-day activities, you can day-to-day activities, I mean by coding activities, so you can definitely grasp, okay, this code is doing what. So if there is any error or debug and all those stuff, mostly you can solve it and you can understand the flow. That's it. Okay, so our modules we have already imported. Now the next stuff, let me bring it here, is the model. Okay, and what is the model? As we have mentioned, we are going to build one sequential model. So from neural network module we use the sequential function basically. So you can see what this sequential does. It is nothing but a sequential container. This modules will be added, blah 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 stuff. You have the forward method, sequential accepts the input and forward it to the first module. It contains, it changes the output. So it's nothing but it builds the sequential neural network. That means the stack of the layers of your model, right? Input layer, hidden layer, hidden layer, hidden layer, output layer, that thing, and also in between the activations. So one important thing you have to understand here, if you see in this example as well, right, the ReLU is written next to the layer, okay, not inside the layer. Likewise in TensorFlow you can also mention the activation inside the layers, right? So this is very important thing, that and also very beneficial to understand that PyTorch accepts the your activations as a separate entity or separate parameter, not parameter, I will say separate entity. And that's the beauty of it. You can customize it based on your requirement, and you can change in any layer anything, any activation basically what you want. Okay, so same thing there also possible, but here it's more modular. Okay, so first thing, so if you see one linear basically layer where we are providing that, okay, I have 10 dimensions or 10 neurons, basically 10 inputs, and I need 16 nodes of hidden layer. And once this will be created like this, dot 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 10, and from 10 16, something like that here, and one that is created, I'll be requiring one activation. So I'm passing activation and I'm using activation ReLU here. So you can see the definition, okay, how ReLU works. ReLU is nothing but max of your 0 comma x, based on x is positive. Okay, now once the activation layer activates and makes the whole system non-linear, I'm again creating another layer. Basically this will be my output layer, another hidden connected with from that 16 I'm connecting to one output layer, and the output layer will have one basically neuron. That's my output neuron. And as we are solving for, let's say, a binary classification, dummy binary classification, our output will be having a sigmoid, nn.sigmoid. And mostly we don't use sigmoid in real world, but for showcasing here we are using nn.sigmoid as an output. Okay, and this is my another activation. So two activations we have used, and you have seen how to write down activations inside sequential in PyTorch model. So once the model is ready, I'll just run the model, then just print the model so that you can see how it creates. So first you have the linear where your input feature has 10 inputs, and your output feature has 16 inputs, and you are not passing any and you also passing bias here, right? Okay, so by default bias is true always. Then you are passing a ReLU sigmoid, ReLU activation function, then again another linear layer, and then you are passing another activation, and that activation is sigmoid. That will be your output layer. Okay, so your model is ready. Okay, now let's create the data. So what we have passed, we have passed that our input features has 10 number of features, right? So let's just create one tensor x, and let's print the x. So you can see 10 features, and we have 4 set of examples. So 1 2 3 4 set of examples is each example contains 10 vectors, 10 columns of vectors. That means this will be, let's say, x1 x2 x3 x4 x5 blah blah stuff. Okay, so this is our tensor, and the tensor is ready to go along with the model. Okay, so my output from this will be, I have created the instance of model. Right here we have created model, and inside the model will be requiring the input, and that will provide me the output, and that's it. Okay, and if you print the output, you will see this is the output. Okay, that sigmoid backpropagation, it gives you the probability between 0 to 1, right? That's what sigmoid function does. Now based on your thresholding criteria, let's say you have 0.5 as threshold criteria, this will go to 0 0 1 0, something like that, right? So that's how your classification will work here. Now, okay, you have to add one loss function and optimizer. Okay, so let's just copy those, and we are adding binary cross entropy as loss, and we are using Adam as optimization method. Okay, with a learning rate of 0.001, and once that is done, okay, let's create a dummy target. So what this output does, it gives you the output of the model. Okay, what the model will output based on the input. Okay, this is the very random thing. Okay, now what you are trying to do, now you are trying to train. So for training you will be requiring the actual output. So here the actual output, you can see the labels between 0 and 1, and now let's say for 100 epoch I want to train. So we have seen the same thing, right? How to train. First we'll be doing the outputs, that will be model X, then you are computing the loss, and then you are resetting the gradient to 0 basically. Then you are doing back propagation, and based on the value of back propagation you are just updating the steps. So 5 steps, right? These 5 steps we are doing, and for every 20 epoch, previously we have done it for 10 epochs, we'll just printing the loss. Okay, so you can see the loss is gradually decreasing, and that's it. For this video, mostly here we just wanted to share how to use activation inside your model. So this is, you can use activation inside your model. So yeah, that's it for this video. In the next video we'll try to slowly dig deeper into deep learning and all those stuffs using PyTorch. So yeah, this understanding of the syntax is very important. You don't have to run the code, you just go through the videos in 2x 3x 4x whatever you feels like, and just understand. And you have ChatGPT with you as well. Just if you are curious, you are not understanding anything, just copy paste and ask ChatGPT, they will give you the solution. I'm just helping you to narrow it down what to study and how to study. That's